Welcome to GW Integrative Medicine, the podcast about disease prevention and health promotion from the Office of Integrative Medicine and Health at the George Washington University School of Medicine and Health Sciences. I'm Dr. Leigh Frame, Director of the Integrative Medicine programs here at GW.
I'm Dr. Emily Ho, Director of the Linus Pauling Institute and a professor in the College of Public Health and Human Sciences at Oregon State University. Today, we're going to talk all things about vitamin E. And there's no better person to address that question than the Linus Pauling Institute's own goddess of vitamin E, Dr. Maret Traber. Like me, Dr. Traber is also professor in the College of Public Health and Human Sciences at Oregon State University. She's also a principal investigator and the Helen Pauling Endowed professor at the Linus Pauling Institute.
The Linus Pauling Institute is a world leader in the study of micronutrients, phytochemicals, and other dietary factors, and the role those compounds can play in promoting optimum health or preventing and treating disease.
Dr. Traber is one of the leading experts in vitamin E. Her research focuses on understanding how to best define vitamin E requirements. This includes some fundamental questions, seemingly as basic as, why do we need it and how much do we need to stay in good health?
We are so excited to welcome you today. So welcome to GW Integrative Medicine, Maret.
Well, thank you very much for inviting me. I'm always thrilled to talk about vitamin E.
I understand that. We all have our little pet nutrient. So please tell us a little bit more about yours. Vitamin E is classified as a fat-soluble antioxidant. Can you tell us exactly what that means and why that makes it important?
So vitamin E dissolves in fats, and that's where you find it. So many people who try and eat a low-fat diet actually end up becoming really low in their intake of vitamin E. It's present in foods like olive oil, nuts, and seeds. So if you're a fan of hazelnuts or almonds, you get a good intake of vitamin E. You need it to protect membranes, especially polyunsaturated fats.
So when we talk about vitamin E, we're actually talking about a bunch of things. What are the different forms of vitamin E?
Oh, goodness. This is so confusing for people. There are 8 different forms that plants make, as well as 8 different forms when they're chemically synthesized by chemical companies. So when you go to buy vitamin E, you might see natural source alpha tocopherol, or you could see mixed tocopherols, or you could see tocotrienols, or you could see all racemic alpha tocopherol. Honestly, the form that the body likes is alpha tocopherol, and the body is so clever, it can pick out the natural shape of the vitamin E. So even though the chemical form has 8 different structures, only half of them, 4, are in the 2R forms.
So when we talk about, those almonds that you mentioned were a good source versus a supplement that you may take, are there differences in those forms then?
The form in the grocery store is tocopherol acetate because that protects the vitamin E from the oxygen in the air. The almond really wants vitamin E to be effective at protecting the nut and the oils in the nut. So it is the free alpha tocopherol. So it's readily absorbed in that form.
Never realized they were so complicated.
Wow, so that's a lot to think about. I know we on this podcast are very pro-food first, and it sounds like almonds, which I'm personally a huge fan of, are a really great source of vitamin D, but maybe people aren't eating enough almonds. So are we getting enough vitamin E, or should I say enough vitamin E's?
Well, I'd like to terrify your audience by telling them that 96% of women don't get the amount that's recommended for alpha tocopherol. And that's the form of vitamin E that actually serves as the amount you, or the kind of vitamin E you should get in the diet. most people are not big fans of nuts either. So if you really like spinach or kale, those are great sources of vitamin E also. So it sounds like a lot, but a cup of cooked spinach would get your dietary requirement. If you do like nuts and seeds, sunflower seeds, hazelnuts are also good sources of alpha tocopherol. Surprisingly, walnuts have a lot of gamma tocopherol. And similarly, soybean oil has more gamma tocopherol than alpha. And we don't really understand why the plants make these various different forms. It's interesting that palm oil is really rich in tocotrienols as well as alpha tocopherol. So it's very confusing, even for a vitamin E expert.
Can we circle back to the supplements? There seems to be a lot of warnings given about taking vitamin E supplements. So why has vitamin E specifically been called out in terms of being cautious about? And is this caution really warranted?
Well, that's an excellent question. It turns out that in the late 90s, early 2000s, vitamin E was really thought to be wonderful to protect you from heart disease. And in fact, there were several trials that were done to see could vitamin E prevent heart disease, or if you'd had a heart attack again, stop that heart attack from happening ever again. And those trials had really mixed results. And about 2005, Dr. Edgar Miller published a paper that claimed 400 IUs of vitamin E as a supplement was associated with a 5% increase in risk of dying. And this seemed to be, you know, man bites dog kind of story, and it was all over the news. Everybody was very concerned. Um, and there have been several trials since then, several dozen meta analyses, and it's pretty much whatever you think, you can find papers to support your position. The randomized clinical trials show that in women, 600 IU for 10 years in a randomized clinical trial actually decreased venous thrombosis, which means blood clots in the veins. Those authors even claimed that vitamin E was better than warfarin to prevent blood clotting. At the same time, there have been other studies that claim that, well, vitamin E decreases HDL or vitamin E increases um, left ventricular dysfunction in the heart. So we're left with this very confusing issue. I've looked at this really closely. The different effects or adverse effects people report are different in every study, which means that there's really nobody who knows exactly what's going wrong. And just to confuse you further, what I think is it may be that vitamin E supplements taken by people who don't eat a lot of green leafy vegetables, they decrease their vitamin K. And vitamin K is important for activating 17 different proteins. Most of these are involved in regulating calcium. So you can have calcium precipitation on the artery wall if you're low in vitamin K because it's needed for matrix GLA protein. So I think the whole issue of if you're going to take vitamin E supplements because they might be beneficial for your eyes or for fatty liver disease, or just because you don't care for eating lots of fat and nuts and seeds, and you want to have a low fat diet and eat your supplements instead, I recommend that you eat lots of green leafy vegetables. And Emily, you won't be surprised, but broccoli. Broccoli also has a fair amount of vitamin E.
Yeah, broccoli. Is there nothing it can't do?
Yeah, I always endorse eating broccoli as well for lots of reasons.
Yes, this is really fascinating. And I think I know I personally have had this conversation with people about the confusion of supplements versus food and how much to take. And I feel like the moral of the story often is really the best medicine is a healthy, diverse diet. And if you can try and get as much different kinds of plants and in your diet on a regular basis, that you're going to hit all of these bars and you won't have to worry too much about this. That being said, that can be really difficult for people. So what would we tell those people who are really struggling with having a healthy diet for one reason or another? It's preference, it's cultural. Perhaps it has something to do with some other disorder they have where they can't eat certain foods. What would we tell them to do?
Well, one of the things I like to recommend is multivitamins. They tend to have the RDAs of all of the major vitamins and minerals. If you get a high quality supplement, you can pretty much I view it as insurance. And for people who are thinking, gee, well, I like to get 400 IUs of vitamin E, that number was just really picked out of the air by the companies that make vitamin E pills. The RDA is set at 15 milligrams, which is the amount that is in multivitamin pills. So if you really are not a fan of green leafy vegetables, that's where I would get my vitamins.
Thank you. That is very helpful. Somewhat related to that, traditionally, vitamin E was thought of in association with pregnancy, which maybe people don't really know. But what is the association there, and what is the role of vitamin E in development and maybe the need for supplements or not?
I am so glad you asked because I was stunned when I looked into the vitamins that are given during pregnancy. The major medical associations now are not advocating vitamin E in those supplements, and so they're not there. I was very surprised, and I'm surprised because we have been studying what the embryo needs in terms of nutrients. And it sounds silly to say, but we're using zebrafish embryos. It turns out those little aquarium fish, they're about an inch long and have stripes, so they're called zebrafish. You can encourage them to lay eggs by turning on the lights and turning off the lights. And you know exactly how old the eggs are. And these fertilized eggs then grow to be swimming fish in 5 days. So we figured out how to feed the adults a vitamin E deficient diet. This generates vitamin E deficient embryos, and we can study what does the embryo need. Surprise, surprise. Vitamin E is absolutely required by the embryo for brain and neural tube. And we looked at the metabolism, what was happening in the animal. And what we discovered was not only is vitamin E needed to protect the polyunsaturated fish oils, it also is needed to protect the metabolism, which ultimately ends up destroying choline, and that impacts folic acid metabolism. And we think the embryos are developing neural tube defects because of inadequate vitamin E. We've got several papers over the last 15 years that we've published on this issue, but I think it's very important to recognize this is done in animals, but vitamin E was discovered because it's needed for protecting the embryo in pregnant rats. And what we also know is that the same time we're seeing defects in the zebrafish embryo, that level of development is when those rat embryos died. And it's also prior to when a woman knows she's pregnant. Now, you're, I'm sure, thinking, well, a fish egg develops out in the water all by itself. A human embryo implants and gets nutrients from the mom. Well, we're talking about a stage before implantation. So this is really early in pregnancy. And that's why I recommend, if you're thinking about getting pregnant, take those multivitamins that have vitamin E. It doesn't have huge amounts, it has the requirement. And that's what would protect any developing fetus.
It's amazing how all these nutrients are interconnected, though. It's always such a tangled web when we think about foods, our bodies, and what they do. So we've been talking a little bit about all the different forms of vitamin E, what they do. Can you tell us a little bit more? How do our bodies use that vitamin E? How does the vitamin E actually get to the brain? How does it get to the embryo? And second part of the question is, does it change? Does it change during pregnancy? Does it change when you have a disease?
Okay, I'm hoping you have about 3 days to discuss that question. um, One of the things I'm famous for is using labeled vitamin E to trace where it's going. And so we give labeled vitamin E to people. And my latest study is in women, and we tried to figure out how much vitamin E gets absorbed. It turns out about 50% of what you eat. And so that's not a surprising number. That's what we expected. What happens to the vitamin E, though, is it gets into the small intestine where it's packaged in what's called chylomicrons. These are, you can imagine, semi trucks moving the dietary fat into the circulation and delivering it to the liver. It's then the liver's job to take this vitamin E. And remember, you could be eating a whole bunch of different plants. You could have alpha tocopherol, gamma tocopherol, tocotrienols, all those different kinds. The body puts them all into the chylomicrons, ships them to the liver, and then the liver has a special protein called the alpha tocopherol transfer protein. And that protein grabs the alpha tocopherol and puts it back in the circulation in lipoproteins. You've heard of that bad cholesterol, LDL? Well, it's the form that actually moves the vitamin E into the circulation and delivers it to tissues. I actually have studied human placentas. This is way back in the last millennium when I was at NYU, and we were trying to figure out, how does vitamin E get to the developing embryo and the fetus over time. A lot of other work has been done since that time, but it's very interesting. Placental cells actually make receptors for what's called a very low density lipoprotein that's secreted by the liver and carries vitamin E into the circulation. It is the precursor of LDL. But these receptors are like little mailboxes. They are ready to grab onto the VLDL and move it into the placental cell. And in this way, it's protecting the placenta and providing enough vitamin E there. The transfer from the placenta to the developing baby is not well understood at all. And we've tried to do some studies looking at cord blood. Can we really interpret what is going on? It's amazing, but babies are born with vitamin E levels that are deficient. And to study this, we did some studies in pigs. We actually gave stable isotope labeled vitamin E to pig moms and then measured how much vitamin E was in the pig babies and then in their blood. And it was absolutely stunning. Yes, the baby is born E deficient, but then it starts drinking mother's milk. And surprisingly, in less than a week, the tissues in the baby pigs increased tenfold. So we have a fantastic system for getting that vitamin E to the baby once it's breathing oxygen and out of the mom, but it's totally unclear. And that's what's happening. How do you get vitamin E from the placenta to the baby? We still don't really understand that. It seems to be quite limited, which is probably why um, whatever mechanisms you can get the vitamin E into the egg ahead of time is probably useful for the developing baby. So, if we think about adults, we get our vitamin E from the diet, we transfer it from the intestine into the liver. And then the liver's job is to sort out all those different forms of vitamin E that are in the diet. It puts alpha tocopherol in the circulation, and that's what gets delivered by lipoproteins to all of the different tissues, including the brain. And what happens in the liver is kind of interesting also, because the liver's job is to detoxify us. And it gets very aggressive about removing forms of vitamin E that are not alpha tocopherol. And those get metabolized and excreted both in the urine and in the feces. So all those odd forms of vitamin E that are not alpha tocopherol are not the ones that the body retains. So it's, I think, very interesting. There are advocates of gamma tocopherol who think that it has a structure that might be useful because it can detoxify radical nitrogens. And peroxynitrite is studied by one of the LPI investigators, Joe Beckman. It's possible that peroxynitrite is an important factor in Lou Gehrig's disease or ALS, but it's not clear that eating gamma tocopherol, whether as a supplement or in food, is actually detoxifying nitrogens, because the body rapidly metabolizes it and excretes it. Gamma tocopherol may have some benefit in the small intestine, protecting against inflammation, but even that has not been shown to be um, a, a sufficiently important factor to make gamma tocopherol a vitamin. So, to repeat, only alpha tocopherol is what the body requires. And that's the reason for the tocopherol transfer protein. And what's interesting about the tocopherol transfer protein is that that protein, if you have a genetic defect, then you end up with so severe vitamin E deficiency and neurologic disease that you end up with, essentially, it starts off you not being able to feel your toes and fingers, and then it progresses to not being able to walk. And children are where this is often seen, because the genetic defect as they're growing means they don't get enough vitamin E, and there have even been reported deaths in children from vitamin E deficiency.
That is fascinating. And it really makes me wonder about all the supplements out there with all these different kinds, and is there any negative to taking, a mixed tocopherol and having all these different kinds that the body then just has to detoxify and excrete?
Well, I guess the major downside to supplements with all the different forms of vitamin E is the expense of buying them. That's probably not what the manufacturers would like you to hear, but it's a concern to me because I think if people are going to spend their money on supplements, they should get the kinds that actually are going to do something useful for the body. And that's where I think the alpha tocopherol is important. The other forms are likely to, even though they get absorbed, to be excreted right away. So you don't end up having very much benefit from them.
So, Maret, what's the take home then? What are some of the best ways to get our vitamin E that our bodies need?
I think the best way is through the diet myself. I'm a big fan of fruits and vegetables, spinach, kale, broccoli. I think having it sounds almost too simple, but the 5 to 9 servings of fruits and vegetables a day, all different colors, is hugely important. We as nutritionists, I hesitate to say, really don't know everything beneficial in those diets. We're studying at the Linus Pauling Institute all kinds of bioactive compounds in not only fruits and vegetables, but spices, wines, oils, to look for what are some of these minor components that may have huge benefit if you consume them.
Well, you're definitely preaching to the choir here on that one.
Definitely. Well, we could spend days talking about this. It's really fascinating, but I think that's all the time we have for today. Thank you for joining us, Maret.
Well, it's been my pleasure, and anytime you want to talk more about vitamin E, let me know.
We will definitely do that.
We can also see more of Maret's articles at the Linus Pauling Institute website and our Micronutrient Information Center that has a whole massive chapter on vitamin E.
This is the GW Integrative Medicine podcast from the GW Office of Integrative Medicine and Health. I'm Dr. Leigh Frame.
And I'm Dr. Emily Ho.
Thanks for listening.